There are some series that have positive and negative terms, but that are not alternating series. An example might be the sum n equals 1 to infinity of the cosine of n over n squared. So if I look at some of the terms, I have the cosine of 1 over 1 plus a cosine of 2 over 4 plus a cosine of 3 over 9, and so on. So the bottom's always positive, but the cosine could be positive or negative. It depends on what quadrant you're in. But I do know in this case that I know that my cosine will always fall between 1 and -1 no matter what. So I can compare the absolute value of cosine n over n squared, the absolute value, to 1 over n squared. And I know it's going to be less than that all the time because these numbers are less than 1, or less than or equal to 1. Okay? So for any n that is greater than or equal to 1, I'm good. And I know that this series converges. So I also know by the direct comparison test that this other series converges as well. So I know that this converges by the direct comparison test, even though it's not alternating, but it has positive and negative terms. So I have a theorem. It's called the absolute convergence theorem. And it says if a series in absolute value converges, I know that also will converge. So I'm going to give you two definitions of absolute and conditional convergence. So the first one is the series A sub n is absolutely convergent when absolute value of the series converges. So I know it's absolutely convergent. And I also know that a series can be conditionally convergent when my original series converges, but the absolute value of that series diverges.